All right, here we have a word problem. It's a related rates problem. So number 96, a family drives 1,080 miles to a vacation lodge. On the return trip, it takes the family 2.5 hours longer, traveling at an average speed that is 6 miles an hour, 6 miles per hour slower to drive the same distance. Determine the average speed on the way to the lodge. All right, so this is a related rates problem where we're going to make that table with distance, rate, and time. And the reason why I know that is because we're given the distance and we're given a relationship between the rates and the time. So a related rates problem I would define as when between distance, rate, and time, you know the facts of one of them, like you know the distance, you know the exact rate, you know the exact time, and then the other two, you're given relationships between them. And the way I approach these is to set up a table and then make a system of equations, and then just use the calculator to solve. So right now I'm going to get my calculator ready while I make my table. So we have distance, rate, and time. And the two horizontal rows will be like the faster way and the slower way. Okay? Now, either way, the family is traveling either to or from their vacation lodge, right? And that's going to be 1,080. And that's going to be 1,080 miles. So if our distance is in miles, we want to make sure that our rate is also in miles per some sort of time unit. Okay? And if we keep reading, on the return trip, okay, so we can also have made our horizontal rows to and returning. On the return trip, it takes the family 2.5 hours longer. Okay, so that means that our time is in hours, so our rate will be in miles per hour. And we don't know how long it took when the family drove to their lodge originally, but we know that when they were driving home, it took them a longer time by 2.5 hours. So if t is the original time it took, then t plus 2.5 could be the expression for the slower time. And if we keep reading, it'll give us a relationship between the rates. All right, it says that when it took them longer, they were traveling at an average speed that was 6 miles per hour slower, and it was the same distance. So we want to find the average speed, so we're going to look for r. So in this middle column, I'll make r the original rate, and the slower rate is going to be r minus 6, and 6 is in miles per hour, so that's good. Now we have to set up a system, and you need to know that distance is equal to rate times time. So we can use this table to create two equations. 1080 equals r times t. 1080 equals r minus 6 times t plus 2.5. Then we have to solve that system. Now at this point on a calculator, like any word problem, I think any teacher will let you use a calculator to solve this. So I encourage you to have a TI-inspired CAS, which will just solve this for you. But let's say you don't have a CAS, then this is the equation that you would solve. All right, you don't want to set 1080 equal to 1080 and then substitute RT in on the left side and R minus 6 times T plus 2.5 in on the right side. All right, you don't want to substitute in for a constant because then we create an equation with two variables and only one equation, so we can't solve that. So we want to avoid that. Instead, we want to substitute in one variable for another variable. So if we take this top equation and you divide both sides by r, you get 1080 over r equals t. Then you could take this bottom equation and substitute in 1080 over r in for t. So it would look like this. All right, and then this is just a rational equation which you could solve on your calculator, all right, by either graphing if you don't have a TI-inspired CAS, or by multiplying it out and then, solving this rational equation. Now, if you have a CAS, then all you got to do is solve the system. So that's how I'm going to show you how to do it. So here's my calculator. All right, does it want to open? It's coming. So I'm going to go to the home screen, open up a new document. I'm going to add a calculator. I'm going to go menu, algebra. And because it's a system of equations, I don't want to do solve. I'm going to do solve system of equations. And it's not linear because we're multiplying variables together. All right, so we're going to do solve system of equations. Linear equations you can do on any type of TI Inspire, but nonlinear systems, it needs to be a CAS. So I highly encourage you to get a CAS. All right, so I got two equations, two variables. I could change it to R and T, rate and time. I'm going to type in my system, which was 1080 equals R times T, and 1080 equals R minus 6 times T plus 2.5. Enter. So we get, if the rate was negative 48 miles per hour, the time was negative 22 hours. All right. Because the domain of rate and time in this question has to be non-negative numbers, we're going to ignore this first set of answers right here. This we're not going to ignore. So the original rate was 54 miles per hour, and it took them 20 hours. All right. And that checks out. If you do 54 times 20, that's 1080. That's the distance. And if you subtract 6 from 54 and add 2.5 to 20, that also multiplies to 1080. So that's your answer. The original rate, which is what it was asking for, was 54 miles per hour.